In this session of the subject Microprocessor and Interfaces for 4th semester Computer Science Engineering, we will discuss about generations of microprocessor. My session outlines are generation of microprocessors, where we will classify various microprocessors on the basis of the generations like first generation, second generation, third, fourth, fifth, sixth generation, where the microprocessors are classified into various generations on the basis of the invention year, the length of the data bus, or the clock frequency. Further, there will be a classification of microprocessor on the basis of the architecture we use. Then we will discuss about advantages of microprocessors, disadvantages of microprocessors, and applications of microprocessor in the last. The microprocessor is a silicon chip that comprises millions of transistors and other electronic components that process millions of instructions per second. It is a versatile chip that is combined with memory and special purpose chips and pre-programmed by a software. It accepts digital data as input and processes it according to the instructions stored in the memory. The microprocessor has many functions like functions of data storage, interact with various other devices, and other time related functions. Therefore, a microprocessor interfaced with memory and input output devices forms a microcomputer. This is a present day microprocessor. Evolution of microprocessor. Microprocessors are nowadays an essential part of all gadgets which we are used in day-to-day life. The evolution of microprocessors is divided into 5 to 6 various generations, such as first generation, second generation, third generation, fourth generation, fifth generation, sixth, and the characteristic of these generations are discussed. Here it is. This chart shows the various generations of microprocessor, starting with 8080 microprocessor, the invention year 1974, the number of transistor it used, the data width means the length of the data bus, the clock speed, either it is 2 megahertz or up to. In the last, we can consider it as a Pentium 4, which was invented in the year 2000. The number of transistors it uses, the length of the data bus, and the clock speed 1.5 gigahertz. So, this table shows a broad comparison of the various generation of microprocessors. First generation microprocessor. The first generation microprocessors were introduced in the year 1971 to 72 with the advent of IC technology. The instructions of these microprocessors were processed serially. They fetched the instruction, decoded, and then executed it. When an instruction of the microprocessor was finished, then the microprocessor updates the instruction pointer and fetched the next instruction, performing this consecutive operation for each instruction in turn. The example of first generation computers are 4-bit microprocessors and 8-bit microprocessors. In 4-bit microprocessors, we are having Intel 4004, Intel 4040, Fairchild PPS 25, Rockwell PPS 4. The example of 8-bit microprocessor is National IMP 8, Rockwell PPS 8, AMI 7200, MOSTEC 5065. The second generation microprocessor was introduced in the year 1973 and used NMOS technology, which offered faster speed, higher density, and still better reliability. The second generation of the microprocessor is defined by overlapped fetch, decode, and execute the steps. When the first instruction is processed in the execution unit, then the second instruction is decoded and the third instruction is fetched. The example of 8-bit microprocessors is Intel 8080, Intel 8085, Fairchild F8, Motorola M6800, Zilog Z80. The 12-bit microprocessors are Intercell 6100, Toshiba TLCS12. The advantages of second generation microprocessor: larger chip size, 40 pins, they were in the DIP package, dual in package, more number of on-chip decoded timing signals, ability to address larger memory space, ability to address more I/O ports, more powerful instruction set, faster operations, better interrupt handling capabilities. 8085 executed 0.5 million instructions per second, or speeds were 0.5 MIPS. The third generation microprocessors are introduced in the year 1978 with the invent of HMOS, high density MOS technology. These were 16-bit microprocessors with a performance like mini computers. The microprocessors were different from the previous generations of the microprocessors in that all main workstation industrialists began evolving their own ECE based microprocessor architecture. The example of 16-bit processor is Intel 8086, Intel 8088, Intel 8018, Intel 286, Motorola 68000, Motorola 68010, National NS 16016, Texas Instruments TMS 99000, 6100, Toshiba TLCS 12, Zilog Z 8000. Characteristic third generation. These microprocessors were 40, 48, and 64 pins IC, high speed and very strong processing capability, easier to program, allow for dynamically relocated programs. Size of internal registers were 8, 16, or 32 bits. Microprocessor had the multiply, divide, and arithmetic hardware inbuilt. Physical memory space was from 1 to 16 megabytes. Flexible input addresses, more powerful interrupt and where capabilities, segmented address, and virtual memory features. Fourth generation microprocessors. The fourth generation microprocessors are entered with design within transistors in the year 1985 to 89. These microprocessors are of low power version of HMOS technology. The instruction set of the 80386 microprocessor was upward compatible with the earlier 8086, 8088, and 80286 microprocessors. Leading microprocessors like Motorola, the 8100, and Intel's 8096 could issue retire more than one instructions per clock cycle. 80486 executes 54 billion instructions per second. Example of 32-bit microprocessor: 80386, Intel 80486, National NS 160, Motorola M68020, M68030, Belmac 32. Fifth generation microprocessors were introduced by Intel Corporation in 1993 in the Pentium with 64 data bus. Generation microprocessors employed decoupled superscalar processing, and their design soon exceeded 10 million transistors. The two introductory versions of Pentium operate with a clock frequency of 60 MHz and 66 MHz and a speed of 110 million instructions per second. In fifth generation, PCs are a low margin, high voluminous, conquered by a single microprocessor. The sixth generation microprocessors were introduced in the year 1995, having better architecture but more in size. The Pentium Pro microprocessor contained 21 million transistors, 3 integer units, as well as floating unit to increase the performance of most softwares. The basic clock frequency is 150 MHz and 166 MHz. Now, the types of microprocessor or the classification of microprocessor on the basis of the architecture. They are further classified into two types: RISC, CISC, ASIC, superscalar, and DSP. RISC, reduced instruction set microprocessor; CISC, complex instruction set microprocessors; ASIC, application specific integrated circuit; superscalar processors; DSP, digital signal microprocessors. Now consider them one by one. RISC. RISC stands for Reduced Instruction Set Computers. It is designed to reduce the execution time by simplifying the instruction set of the computer. Using RISC processors, each instruction requires only one clock cycle to execute, results in uniform execution time. This reduces the efficiency as there are more lines of code. Hence, RAM is needed to store the instructions. The compilers also has to work more to convert high-level language instructions into machine language. Some of the RISC processors are PowerPC 601, 604, 615, 60, DEC Alpha 210, 642, 211, and so on. MIPS TS R10000 RISC processors or HP 7100LC. The architecture. This microprocessor architecture uses high optimized set of instructions. It is used in portable devices like Apple iPod to its power efficiency. Characteristics of RISC architecture. The major characteristic of RISC processor are: it consists of simple instructions, it supports various data type formats, it utilizes simple address modes and fixed length instructions for pipeline. It supports register to use in just one cycle. Execute time. Load and store instructions are used as the memory location. It consists of large number of registers. It consists of less number of transistors. This is a diagram representation of RISC architecture. CISC. CISC stands for Complex Instruction Set Computer. It is designed to minimize the number of instructions per program, ignoring the numericals per instruction. The emphasis is on building complex instructions directly into the hardware. The compiler has to be very little work to translate a high-level language to a C-level language or in code. Because the length of the code is relatively short, so very little RAM is required to store the instructions. Some of the CISC processors are IBM 370 or 168, VAX, VAX11/780, Intel 80486. Architecture of CISC. This architecture is designed to decrease the memory cost because more storage is needed in larger programs, resulting in higher memory cost. To resolve this, the number of instructions per program can be reduced by embedding the number of operations in a single instruction. Characteristics of CISC. Variety of address moves are available here. It's large, very length of instruction points. Several cycles may be required to execute one instruction. Instruction decoding logic is complex. One instruction is required to support multiple add modes. This is again the CISC architecture. Discussed difference between RISC and CISC architecture. RISC, reduced instruction set computer. CISC is a complex instruction set. The microprocessor is designed hardware control. Here it is designed code control. It executes at least one cycle. Here several will be required to execute one instruction. The instruction have simple fixed format with few addressing modes. Variable formats with several complex addressing modes. It has several general purpose registers and logic cache memory. It has a small number of general purpose registers. Instruction set of RISC microprocessors typically include only register to register load and the instruction set of CISC microprocessor includes several instructions to access memory and CPU registers. Pipelining and superscalar are the base methods to design RISC processor. Pipelining superscalar features are not the basis to design such processors. They are having several features if risks such as pipelining to increase performance. Superscalar microprocessors. Superscalar processors specify the hardware on the processor to perform this task at a time. These processors can be used for ALUs or multipliers. They have different units and these processors can carry out one command by continuously transferring several instructions to the extra operational units inside the processor. A application-specific integrated circuit processor are used for particular purpose that includes automated emission control or personal assistance computer. This type of processor is made with proper specification, but apart from these, can also be made with the self gears. Digital signal multiprocessors. Digital signal processors are also known as PICs. These processors are used to encode and decode videos to convert the digital to analog to digital signal. They need a microprocessor that is excellent in mathematics. The chip of this processor are in radar, home theaters, sonar, set box, and mobile phones. There are many companies like Intel, Motorola, ECE, Digital Equipment and Instrument associated with many processors such as 8085 processors, SA, CISM, RISC, DSPs, and 8086 like Intel. Advantages and disadvantages of microprocessors. The advantages of microprocessors Programmability. Sophisticated functions can be provided relatively easily in software. Performance. Once in integrated are faster and more for microprocessors. Reliability. Integrated circuits are highly reliable. Solid state microprocessors have no moving parts. More and more functionalities can be packed onto a single microprocessor or microcontroller chip. Cost effectiveness. Microprocessors, because they are multiple, are effective in large quantity to minimize their cost. The disadvantages of microprocessor might get overheated, and the limitation of microprocessor imposes on size of data. Ding 2 for microprocessor assembly language program primitive compared to the level programs in high level languages. Applications of microprocessor. Applications of the microprocessors are in special purpose computer calculation, personal assistance, speed, single computers, personal computers, office publication and automation, main game computers. In embedded computers that control automobiles, appliances, instruments, communication systems, foods, factories, assembly lines, refineries, and etc. Example: in a car, microprocessors used in the ignition system, emission control system, anti-lock brake system, dashboard display, entertainment system, navigation, weather control, etc. Modern cars often contain anti. These are the have used in the PPTs. The microprocessor architecture programming application is and microprocessor and interfaces by Douglas V. Hall. In the last, the summary. To understand the working and programming of microprocessors, it is necessary to know the details of evolution of microprocessor. We in this session, the availability of microprocessor with low power, low cost, speed, and computing capability make it useful for applications. Microprocessor-based systems are automatic testing product, signal control system, speed control of motors, etc.